Hello, welcome to my channel. Today we are going to discuss about how to generate three discrete time signals: unit impulse function, unit step function, and a ramp function. Discrete time signals are signals which are defined only at discrete points in time axis. So you will get data values only at discrete points. So without further ado, let's get started with the code. At first we type clear all, close all, and CLC. This is the standard conventional code. Then we need to declare an array that will represent the discrete time variable, which will be a sequence of integers from a particular start to a particular end. So we set the starting index to -10 and we set the ending index to +10. Then we combine the starting index and the ending index to form the discrete time variable array. So n1 semicolon n2. Then we will create a time shift variable for impulse and the step function, which will be for now declared to 0. In this we can input values to shift the graph by the given amount. For now we will keep it 0. Now we will declare a variable that will be the impulse function itself. It will be an array variable with 1 at location 0. So square bracket. So if n is equals to 0, 0 will be equals to 0, which is true. True is 1. So at n is equals to 0, you will get 1 and vice versa. Then we will display it with stem because it's a discrete time graph. N, which is the x-axis, comma del, which is the y-axis. And we display and we hit run. This is our graph. The second graph is the unit step function graph. For this we will replicate the impulse code, but instead of using equals to, we will use greater than or equal to, because we want to assign 1 to values greater than or equal to 0 and 0 elsewhere. We will use the same true and false principle. So u is equals to same square bracket n minus n naught greater than or is equals to 0. We are going to use the same stem function n comma u and hit run. We can see that for values greater than 0 we are getting y-axis 1, and for equal to 0 only we are getting 1. So the third graph is the ramp function, where we will be using something called element wise multiplication, where r is equals to u dot multiplication into n, where each element of r we will be getting will be a multiplication of corresponding elements of u and n, where u is the step function array variable and n is the discrete time variable. The multiplication will be like that, shown on the screen. So basically what we want to do is we want to multiply x-axis with 1 and assign that value to y-axis. So if x is equals to 2, y will be equals to 2. So if x is equals to 10, y is equals to 10. By doing that, we will be creating a ramp function that will increase linearly with time. So if we plot that, n comma r, which is the y-axis, and hit run, so we are getting a linearly increasing with time a ramp function. So we have successfully completed our code and displayed the unit impulse function, unit step function, and the unit ramp function. That's it for today's video. Thank you for watching.